look at atoms and the particles that are in atoms, first I want to show you something on the periodic table. And so this is on the periodic table, this square. Okay, what I wanted to show you is this top number is called the atomic number. And that is equal to the number of protons. Okay, this bottom number is not, it's called the atomic weight, but we are not using that yet. That is not the same thing as the mass number. The mass number is protons plus neutrons, where the number of neutrons depends on the isotope, so you can't just look at that on the periodic table. The atomic number, we already said, is the number of protons. Okay, and the rest are explanatory. So let's look at this atom with this symbol. When we see this top number is the mass number. Okay, so as far as our answers go over here, the mass number for this one is 15. The atomic number for this one, I get that by looking on the periodic table and seeing that its number up here is 7. So it's atomic number 7, and the number of protons, that's what atomic number means, is also 7. Okay, to figure out the number of neutrons, what I do is I use the fact that mass number is protons plus neutrons, and now I know the number of protons, so I can just subtract and figure out how many neutrons. Sometimes we write that over here because it's common to put the, oops, wrong number there, the number of protons there. Okay, and then we can kind of like pretend we're subtracting here. It's more interesting when the numbers are bigger, but we got the idea. So the number of neutrons is 8. And then for the number of electrons, if it's neutral, which this is, so it looks like we have to have 7 electrons. If it's not neutral, you can go by that the charge of the atom is equal to protons minus electrons, since electrons are negative. Let's try one going the other way around. So I've been told the particles. Let's figure out what element it is and so forth. So what element is this? Well, to find out, I need to remember that protons is equal to the atomic number. So I can look on a periodic table and find atomic number 3. And when I do that, it's this lithium. So now I know my element symbol I'll use. Okay. Now if I want the top number, remember the top number is my mass number. Protons and neutrons, and so I was given that. I can add those up. And put a 5 there. And then for the lower number, it's the number of protons, and we know that, 3. On this one for the charge, so I would put the charge in the upper right here. Okay. Or maybe you could just look at that and know protons are positive, and so that's the charge. So there's our answer on that one. The next we're going to look at is nuclear chemistry, nuclear chemical reactions. But before we do that, we need to look at these kinds of particles and what their names are and what they mean. We need to think about these numbers because you really have to be able to connect the numbers to what kind of particle it is. And the top number is the mass number. It's protons plus neutrons. And the bottom number is, it's usually we say it's the number of protons, but we can think of it as the charge. Technically it's the nuclear charge, but that will help you get these numbers. So on the first one, it tells you there's no protons present, but then it has a -1 charge. So this is basically an electron. Technically, it's an electron that came from the nucleus as it decays. And we call that a beta particle. And notice I wrote or because sometimes it can be shown with this beta sign. The next one is a strange one. It's just like an electron, except it has a +1 charge, and this is called a positron. The next one, protons and neutrons, is 1, but then we see the charge is 1 + 1, so this is just a proton. If it were a neutron, like this one down here, it has the 1 for protons and neutrons, but no charge. So this is a neutron. This one, protons plus neutrons, is 4, and then 2 of those are protons. So this one, I wrote He because it's helium. The atomic number here gives you that it's helium. Sometimes it's written with this alpha sign. It is an alpha particle. Let's see how we're going to use these. And the trick is that you know that these numbers are conserved. The upper and lower numbers are conserved. So let's just start with getting the lower numbers on these elements. And our goal is going to be to figure out what other particle must have been given off during this decay. So let's look up uranium and thorium. And they're down here on the periodic table. Uranium is 92 and thorium is 90. So those are the atomic numbers. They go down here. Okay, so we have all our numbers. And what I mean by they're conserved, these numbers have to be the same before and after. In other words, 234 has to be equal to 230 plus what? Well, it looks like I need a 4 there. I do the same thing on the bottom. I'm looking at these. It's 92 equals 90 plus what? Looks like I need a 2 down there. And then we think of our numbers. What has 4 and 2? And it's the alpha particle. So I know this is like that. And of course I could write it like that.